Alright guys, welcome back. Part 2. Math C, accelerated C. You have this slide and this slide, maybe. The first two slides to do. Regular C, we're adding this one here, so accelerated, you do not do that last slide. Okay, thanks. So for this next part, we're talking about circumference and arc length. So circumference is the distance around the outside of my circle. So if I started at this point A and walked all the way around, how many feet, inches, yards, whatever measuring unit I wish to do, does it take me to go around? So when I'm finding circumference, I can take pi times the diameter, which remember the diameter here is in this purple line, so it's all the way across, or 2 pi r. So that's saying I'm taking my radius times 2 to get to the diameter, because radius is just half, and then multiplying it by pi. So same idea here. The reason we need that is because we're going to find what's called arc length. Arc length is the actual physical measure of the arc. In our last video, we talked about talking about the degree. So say I knew this angle here was 25 degrees. Then that arc degree must also be 25 degrees. Well, that helps me a little bit because it helps me take a look at what percentage that arc is, my entire circle. But that doesn't help me if, say, I'm building my own house and I need to know how many feet I need to create my external wall to be. So today we're going to go ahead and talk about finding that length. That length means I'm going to take whatever my measure is, so the actual degree of it. So if it is 25, so I'm going to take that 25 divided by the total of 360 times by my circumference. So circumference, I can either do 2 pi r or just d pi d, which is what we talked about first. So we're going to go ahead and do these first two examples. So my first one, I am looking for the length of AB. So AB is this arc right here. So the degree of that arc will be whatever's the angle associated with it. So that is a nice, lovely 90-degree angle. So this must be therefore 90 degrees. So my formula is that degree measure over 360 times my circumference. So circumference again is 2 pi r or pi times d. Well, if you notice, I'm already given the diameter in this example, so I'm going to have 16 pi. Now, when we do these, since we're getting into the higher level maths, one of the things about doing that is with the higher level math classes, we leave things in terms of pi. We don't actually take it times 3.14. So in your calculators, grab those out, pause if you don't have it. You're going to take 90 divided by 360, hit equals, and then take that times 16. And your answer should give you 4 pi. All right, the second one. Now, we're asked to find BC. Logically, if I looked for BC this way, do I have anything associated with that smaller arc? Maybe just kind of the 15. I don't know what that smaller arc is, so I'm going to actually use the one down here. I gave you the 240 to try and indicate that we're doing the larger side. I should have put another letter in there to indicate we're doing the bigger side. That was my fault. I 100% apologize. Your homework is more clear as to what you're finding the arc length of. So in this case, it's already given to me as the degree. I don't have to change it. I don't have to try and figure out what it is. So I'm going to have 240 divided by 90, or excuse me, divided by 360. My apologies. I looked at 90 and said 90. Over 360 times pi times our diameter. So our radius here is 15, because it's telling me it's 15 here. 15 times 2 would give me 30. So I'm going to take 240 divided by 360, hit equals, then times by 30. should get 20 pi. Again, we're going to leave it in terms of pi. We're not going to actually multiply it out. I know our calculators have that pi button, but when dealing in higher math, we're not going to actually multiply it out. All right, so math, regular C, stay with me. Accelerated C, have fun, do your homework. And these next ones, we're still finding the length of the arc, but we might have to do some of our angle additions to help us determine that. So first I'm looking for SV. So SV is over here. And this is a nice, lovely spot. So I see this little angle is 30, so this must also be 30. So I'm going to have 30 over 360 times by pi and my diameter. So if my radius is 5, my whole diameter has to be 10. So I'm going to have times 10 pi. So in my calculator, I'm going to hit 30 divided by 360, hit equals. Take that number times 10. And you notice you have a nice decimal. Well, we don't want to turn things into decimals. Again, one of the things about higher level math is being able to put things in fractional form. Fractions are more accurate. And it's actually only one extra step for us. So as long as we have our last answer in there, it should work. So what you're going to do is you should see your points 833333333 repeating. In your calculator, you're graphing when you're going to look for the math button. It is right under alpha. Alpha's green. So you're going to hit that math button. And you're going to pull up a menu. And you should see on the very first one, it says FRAC or frac. That means you're going to take your answer and turn it into a fraction. So you're going to hit enter. So it's saying, do you want to turn your answer into a fraction? Yes. Hit enter one more time. And your answer is going to be 5 pi over 6. Now what that's saying is, typically I just say 6 times pi. Well, since pi is a whole number or considered a whole thing, I multiply it to the number on top and then just bring the bottom with it. So in that case, my answer is 5 pi over 6. All right, next one. It's asking me for UV. Now, just like in the example before, this one wasn't very clear as to where I'm going, but if you look down below, it later asked me for UTV. So logically, am I going to do that one twice? No. So when we're doing this UV, we're going to do the smaller one, or the minor arc. Minor arcs, I only need 2 letters. Major arcs, I need 3. So I know VS. I can kind of see SU would have to be 90. So then the whole big thing is going to be 30 plus 90, which is 120. So this whole big giant arc here for the second one is going to be 120 because I added those together. So I'm going to have 120. I'm going to do my work to the side over 360 times 10 pi again. Notice how that part won't change. The only thing changing here will be your fraction. So you have 120 divided by 360. Hit equals. Take that times 10 again. And you notice it's a fraction. So we're going to hit math, frac, yes. And then answer gives me 10 pi over 3. Now I understand that my calculator is not spitting out the pi, but logically we're not multiplying by that pi yet, so we should be recognizing that we need to throw it in. All right, this third one. S-U-T. I cannot really see you too much, so I'm going to erase some of this real quick. Oh, sorry, am I actually in there? You don't need that 120. So I'm going to go ahead and erase it. SUT. So if I already know STU is 90, ST is going all the way through, has an endpoint on each side of the circle, and goes through the center. So that has to be the diameter. The diameter is always a semicircle. So it's always going to be, you guessed it, 180 degrees. So we're going to do this one over here. So I have 180 over 360 times 10 pi. So I'm going to take 180 divided by 360, hit equals, take that times 10. In this case, I get a whole answer. So my answer is going to be 5 pi, just like the one before. So I'm going to write 90 in there so I don't forget that we logically talked about that being 90. So we've done the first 3, so now I'm going to do number 4, which is U. I'm going to erase this part so I can see some more. So UTV, so UTV, so this guy. Alrighty, so we need to figure out what that other piece of my circle is. A couple different ways. You could take 360 minus 90, minus 90, minus 30. Or you could see that here is, again, the diameter is that the diameter, which is 180 degrees. You already have 30 of it. So you could just take 180 minus 30, which would give you 150. But I am asking for UTV, so I need 150 plus 90. So I'm talking about 240 degrees of my circle. So I have 240 over 360 times 10 pi. So I take 240 divided by 360, hit equals, multiply by 10. I get a fraction, or excuse me, I get a decimal, so I change it to a fraction. So my answer is 20 pi over 3. I'm going to erase my line so I can see what I'm asked for next. I'm going to leave my degrees because we were smart and left them so that we would know what to do next. Alright, this next one, this 5th one, I'm looking for UT. So I'm looking right here. Well, isn't that very similar to SU? It's exactly the same piece. So if that's the same piece, I can just say, hey, what was my answer for SU? Oh, I didn't do SU. I did SU, SV. I'm sorry, I can't read today. La la la. I thought I did it, but apparently I didn't. I apologize. Stop. Rewind. Take a breath. We used SU in other pieces. That's how I knew it was already 90. We didn't actually calculate it out yet. So we're going to have 90 over 360 times 10 pi. So I'm going to take 90 divided by 360 times 10. Gives me a decimal, so we're going to change it to a fraction. So this one is 5 pi over 2. Alright, I don't have a whole lot of room to work with on this board, so I'm going to erase some of it since I can't really scroll down. So that way you guys can see. I want you to be able to see where I'm getting my work. So for this next one, I'm going to pick a not fun color so that way we can still follow what's going on, but we don't get confused with other work. So we're going to look for VT. VT is this 150 part. So I have 150 over 360 times 10 pi. So that gives me 150 divided by 360 times 10. Not a pretty answer, so we're going to change it to a fraction. And that one's going to be 25 pi over 6. Let me clean this up a little bit so I can see what I'm looking at. And last one, so we need one more color. Do orangey. I want UVT, so I want U. Sorry, UVT. For some reason I thought I went more. I don't even know. So that is going to be 90 plus 30 plus 150, which gives me 270. So that is 270 over 360 times 10 pi. Again, gives me a decimal, so I have to change it into a fraction. So I get 15 pi over 2. All right. Enjoy your homework.